let us talk about binary heap. Heap is a very specialized data structure and it has a tremendous application. So when we learn binary tree, binary heap is also very interesting, and in this discussion we want to see what is a binary heap, array representation of a binary heap, MinHeap implementation, operations on binary heap, enqueue, dequeue, deletion, delete an arbitrary key, changing the priority of a key, and then building a binary heap from top down and bottom up, and heap application, especially heap sort and heap as a priority queue. So what is a binary heap? A binary heap is a complete binary. Please remember, it's not a full binary, but complete binary means it grows from left to right with one of the following heap order properties. Now heap order, we have two property, one we call MinHeap property, another is MaxHeap property. MinHeap property, each node must have a key that is less or equal to the key. Please remember, less or equal to, that means it can be non-unique. Less or equal to the key of each of the children. Each node must have a key that is less or equal to key of each of its children. That means it may be left, it may be right. MinHeap, the minimum value is at the node. And the MaxHeap, each node must have a key that is greater or equal to each. That means MaxHeap, the node must have a maximum value. So a binary heap satisfying MinHeap property is called MinHeap, and a binary heap satisfying MaxHeap property called MaxHeap. Recall, so what happens? Remember, the nodes are growing from left to right. So it is clearly an example of a binary heap. Now MinHeap and non-MinHeap example, you can see MinHeap means the minimum value is at the node. You can see 13 and the minimum value 3. You see the 13, 16, these are actually 13, 16, 21, 31 like this. We can see the root has the minimum value in case of MinHeap, but there is a minimum value came inside, so it's violating not a heap. Left to right must be the property, that's very important, and it's violate actually structural property, it's also violates structural property. MaxHeap is the maximum number is at the node, so what we can see is the maximum number at the node, but likewise MinHeap is the same, you are violating the property of the heap. Array representation of a binary heap. A heap is a dynamic data structure, is represented and manipulated more efficiently using an array. How? Because since a heap is a complete binary tree, it's very easy. It notes values can be stored in array with the index 0. That means is actually root node is x of I is maybe 0, 1, 2, x of I plus 1 is the left and x of I plus 2 is the right. So you see here x of 0, x of twice I plus 1, x of twice I plus 2, and x of I is 0. So when the root is 0, automatically 13, 21, 16, you see you are following a index automatically traveling across the level. So 13, 21, 16, then 24, 31 and so on, 31, 19, 68 and so on, right? So array representation of binary heap is pretty easy, and we shall use an implementation in such that heap elements are stored in the array. It's very easy to process, all right? So it's very easy to understand and process. Array representation of binary heap. This representation of binary heap in array, several very fast, because add a new node at the end, very easy because it is just order of 1. Add a form a node, find its parent, order of 1, swap, order of 1. So MinHeap implementation, as MinHeap can serve as a priority queue, and a MinHeap class can implement the following priority queue. This is actually Java implementation, we'll see later on the C implementation. The MaxHeap insertion example is same. Suppose this is a heap. Interestingly, what is the maximum value? Oh, this is a MinHeap. So the minimum value is 13. Okay, I want to insert 18. So initially this 18 will be inserted in order to ensure that it is a complete binary tree. So 18 not normally comes actually at a particular place, and then I see that 18 is greater than 31. So I have to go for percolation up. That means I have to swap the value. So when you are swapping 18 and 31, 18 comes up, 31 comes down. You see the next picture. And then again 18 is lower than 21. So again swap, percolate up. And finally you have reached to a place. So we need two percolation. That means whenever we are inserting a number in a heap, based on its value and position, we have percolations to settle the property as a heap. So it can happen in case of MinHeap and also can happen in case of MaxHeap. So MinHeap NQ implementation is this. MinHeap insertion via hole example. You can see here, to insert 18, create a hole at index, and then you are actually filling up the hole, it's like that. So you come 18 greater than 31, percolate, hole up. So you are moving the hole before inserting, and then finally you see 18 is greater than equal to 13, insert 13 in the hole. So hole location is filled. Every time a hole is created and hole is filled up. So MinHeap NQ implementation, DQ implementation is just MinHeap DQ example. I want to delete. MinHeap DQ means I want to delete minimum element. So what we do, we can have replace by value of last node, then delete last node, and then percolate down because I have the lowest value come up and the highest value go into the other area. So via hole also we can do MinHeap implementation, deleting an arbitrary key. You can actually delete this key and you can understand that how do you reallocate. Changing the priority of a key is like this. You have a property, you're changing the property of the key, but either percolation up or percolation down. Building a heap is built actually top down by inserting one key at a time, and after each key insertion, if the heap property is violated, it is restored by percolating the inserted key upward. So I am actually building up a 3C4 6. So 4 6, there is a percolation, right? Because 6, it is actually you can understand I am making a MaxHeap. So 6 is higher, percolation up, percolation down, and so on, and we do it. So converting an array into binary heap, top down precedence rule can be used, converting an array into a MinHeap. So once you have this heap, then you actually try to bring the minimum value on the top, by which you are actually able to achieve, and you can actually have a MinHeap formation after certain amount of percolation. This is an example. Alright, so converting an array to MinHeap is again like this. So heap sort with no stack storage, you can understand that you are sorting based on heap, and each DQ MinHeap size remains same. So heap sort with no stack storage. You can see here no extra charge and you're doing it. So there are heap applications, especially priority queue. Heap can be used as the underlying implementation of priority queue. A priority queue is a data structure, we know all very familiar with it. Items are withdrawn from a property. Maximum priority queues treat low valued key as high frequency, and so on. So up to now we get into the understanding of heap applications.